Okay, graphing sine and cosine with vertical and or horizontal phase shifts. First things first, the graph of f of x equals a sine of bx minus c and f of x equals a cosine bx minus c have the following characteristics, which a couple of them we already know about. We're going to assume that the b value is greater than 0, so it's positive. First off, the amplitude is still the absolute value of a, and the period is 2 pi divided by b. We already know that. We've been working with that for a while. What we really want to learn about today is how to find the left and right endpoints when we have a phase shift. So we're going to be looking at the left and right endpoints of one period of the function, and then once we know that, we can figure out the other portions of the function, the repetitions. But anyway, to find those, we're going to take what was in the parentheses, the bx minus c up here in the formula, and we are going to set it equal to 0. We're going to solve that little equation and for x, and then we're also going to take the bx minus c and set it equal to 2 pi. The reason we're doing that is our normal period, if it hasn't been, if we didn't have a phase shift, the normal period is from 0 to 2 pi. Okay? If there's a phase shift, or if there is a b value that's not equal to 1, then the period shrinks. But normally, just on your parent functions, it's just the parent function sine of x or cosine of x, this is your normal period, 0 to 2 pi. Okay, so let's take a look at this example. We want to graph y equals 1/2 sine of x take away pi over 3. So the first thing we notice is that our amplitude is 1/2, absolute value is 1/2. Our period is 2 pi divided by b, and in this case b is equal to 1, so our period is 2 pi. Okay, so we've got our period now. Now we want to take into consideration that we have a phase shift here of pi over 3. So we're going to take each one of these equations, we're going to set them up, we're going to substitute in our b value, which was 1, our c value, which is pi over 3, and we're going to solve each one of these equations. So pause for a moment, let's get that set up, see if you can solve it, and then I'll be right back with how we got the answer, and you can check your work. Okay, so looking at the graph, or at the problem, we added pi over 3 to both sides. We had set x minus pi over 3 equal to 0. We added pi over 3 to both sides, and we got x was equal to pi over 3. On this one, we had x minus pi over 3 equals 2 pi, so we're going to add pi over 3 to both sides. If you take 2 pi and add pi over 3, you have to get a common denominator. 2 pi is the same as 6 pi over 3. 2 times 3 gives us 6. 6 pi plus 1 pi is equal to 7 pi. This is our preferred way of writing it. It's okay. So anyway, so now we have, this is one of our points where it's touching the midline. Okay, because there's no vertical shift, it's actually on the x-axis, so we have an x-intercept or a midline intercept of pi over 3, 0. This one, we have a midline intercept of 7 pi over 3, 0. And remember, since this is a sine graph, when we have a sine graph, there are 3 points on the midline. We have just found the first one and the last one, so we want to find the one that's halfway in between. So what point is halfway in between? Well, you can take pi over 3 and add 7 pi over 3.
Rodriguez, if you are.
Pardon that interruption. Pi over 3 plus 7 pi over 3, we get 8 pi over 3, and we want to take half of that. So what is half of 8 pi over 3? Well, 8 divided by 2 is 4. So 4 pi over 3 is our middle point that goes right here. So we had pi over 3 right here. We had 7 pi over 3 here. 4 pi over 3 is halfway. So let's go ahead and start sketching this on our graph. Pi over 3. The main points that you need are just the ones that are going to be on your graphs. We've got pi over 3, we've got 7 pi over 3, and then we want that halfway point, which was the 4 pi over 3. And then remember, halfway in between those are where we have our high point and our low point using the amplitude. And for our amplitude, it's up a half and down a half. So we want a point that's up, and we want a point that is down in between these two endpoints and our midpoint. Okay, so now if I sketch this, I have my sine wave, which has the phase shift of pi over 3, and the pi over 3 went to the right because this was subtraction. Remember, when it's subtraction with a phase shift or a horizontal shift, it means that you're going to the right. To finish out, your graph would continue the same in this direction. Okay. With your same points, and you could figure out what these values are. Right. Notice that the difference here was 3 pi over 3, so this would be a difference of 3 pi over 3, or pi, so this would be a negative 2 pi over 3, and this one would be negative 5 pi over 3. So you could figure out how far apart they are based on what this difference was here. And so now we've got our graph with a phase shift of pi over 3. The key, again, is finding the answer to these two equations so that you can find your endpoints of your graph. So go ahead and finish writing that down, record, and I will put one more video up of another example in a little while. Thanks. Bye.